Okay, see Lindelof videos, finding the second derivative implicitly. So here's what the obvious point is going to be. The first thing you have to do is take the first derivative. However, taking second derivative implicitly is a little bit different than it is for other equations. So let's actually do this. Let's take the derivative of this thing right here. So obviously the derivative of x squared is 2x. The derivative of y squared is 2y, dy dx. And the first derivative of 25, which is a constant, is 0, right? Now I'm just going to do the algebra. Take this away here, take this away here, and we get, let's do this. I'll put it over here. 2y dy dx equals negative 2x. I'm going to go ahead and divide here. I'll bring the answer down after I do this, but I'm going to divide both sides by 2y, right? We're trying to get dy dx by itself, right? So 2y. If I simplify this out, I get dy dx is equal to, right, negative 2 over 2 is 1. I'll put the negative in the front, is opposite x over y. All right? So that was pretty simple and pretty quick. So now what I do want to tell you is that we're going to use this again. We're going to use this piece again. So let's move forward. So now we're going to take the derivative of this part, right? So that's where we are right now. So we're going to take the derivative of, right? So I think we can agree that this is the quotient rule, right? So we're going to take, right, now we're looking for the second derivative of y with respect to x. So that's what that looks like, second derivative. So this is quotient rule, isn't it? So I'm just going to make my list of stuff for the quotient rule. Quotient rule, I'm going to need it f of x, and I'm going to say it's x. You're going to see that I'm not going to put this x up or down. I'm just going to leave it there. I'm sorry, the negative side. I'm going to take f prime at x. F prime at x, first derivative of x is 1. I'm going to take g of x, right? I'm gathering my pieces here. G of x is y, and g prime at x is equal to dy dx. And this is where we're going to use the substitution, which, if you remember, is equal to opposite of x over y. So we're going to come back to this. Remember, we're coming back to this piece. So I'm going to drag all this out. So I'm going to start finding this derivative, and I'm going to say that the second derivative dy dx, like this, is equal to, right, is equal to g of x, right, which is y, times the derivative of f of x, which is 1, minus, right, now we take the first function times the derivative of the second function, right, dy dx, all over g of x squared. G of x was y, so y squared. Right? So far, so good. So here's where it gets really, I think it gets pretty interesting, is that we're going to put this in here. We're going to actually substitute this out. So I'm going to substitute this piece out, right? Substitute this piece out, right? That's where dy dx is. But we know that dy dx, right? We know that dy dx is this piece right here. So I'm going to drop that in. And dy dx is the opposite of x over y. This is going to turn into a little bit of algebra. So I clean this up, right? I clean this up, and I get the second derivative is equal to y minus, look, I'm going to multiply this through a negative negative. This positive x times x is x squared over y. It was a crap mess right here, right? So I don't know how much of this you want me to actually go through. I actually cleaned this up. I multiplied this over here by y over y so I could get a common denominator, and I got y. What I get? Y squared plus x squared over y. See, we have a common denominator here of y, right? And then y times y gives me this y squared. All over. This looks like crap for a second. All over y squared. Don't freak out. Don't freak out. This is this, right? So this is rule of complex fractions. So look, I'm just going to write this over here. I got this. Sorry, y squared plus x squared over y, right? I took the reciprocal of this, so this one is this one. This y squared at the top is now at the bottom. So we get our derivative as x squared plus y squared all over y cubed If you want to do this, I mean, it's really weird, but if you want to do this, you can go back and take a look at this. And this is something that I don't know if your professor expects you to do this or not, but I did notice this, that x squared plus y squared is equal to 25. So I can resubstitute this. So instead of putting x squared y squared, I could put 25 over y cubed is equal to the second derivative, right? Right, this, where am I? Right, it's a second derivative, right? So here's the answer. I know, what a pain. Nelson, you asked for this video. I hope that it was helpful to you. If you have any questions or comments, please let me know. And if you haven't already subscribed, please do. I appreciate it.